Hey guys, we're thinking now about quadrilaterals. So we have our four-sided shape. In a quadrilateral sort of family, there are lots of different types of specific quadrilaterals, perhaps just like in your family, right? Like you all fit and you have things that you share in common and you have things that make you uniquely you. So, with that, in a quadrilateral, to be a quadrilateral, you simply need to have four sides and be a closed shape with all straight sides, right? So you can't have any curves to you. Like this one up here, right? So you'll see in this guy here, there aren't any uh, parallel lines, right? There's zero sets of parallel sides. There's not necessarily any truth to any of the sides being the same length, right? They're all different. All of the sides and angles too happen to sort of be different from each other. So this is simply a quadrilateral. That's the most specific thing you can call this shape up top. Now, when you sort of get into classifying or funneling down, making more specific types of quadrilateral statements, the first thing you want to think about is how many sets of parallel lines or parallel sides are there? And so when we look at our hierarchy here, right, we're just sort of going to be making layers underneath of our main red quadrilateral here, thinking about parallel sides. This trapezoid here, you can see these arrows, they tell you that these lines are parallel. So this has one set of parallel sides. A parallelogram has a one little arrow parallel side, and also these lines here or sides are parallel to each other. They're never going to intersect. So a parallelogram has two sets of parallel sides, and a kite here has zero sets of parallel sides. None of them are parallel. So from there, we have these three sort of classifications, but we want to know, can we even go further? Are there any more specific types of quadrilaterals or statements we can make about quadrilaterals relating to their sides or their angles? So we're going to level down. So in order to be a parallelogram, right, you have to have two sets of parallel sides, right? So in that case, from there, you can ask yourself more questions like, do I also have all of my angles being 90 degrees? If so, if you have two sets of parallel sides and you have all 90-degree angles, you can call yourself a rectangle, right? It also requires, within a rectangle, you'll see that the sides have to be the same length as each other. That's part of how they become parallel to each other. So if you do also think about the sides, right? If you're a parallelogram and you have all four sides the same length, you can be a rhombus, right? In a rhombus, you don't have to have right angles like in a rectangle. A rectangle, you have to have right angles and those two sets of parallel sides, right? And opposite sides are the same length. In a rhombus, though, you have to have all of your sides the same length, but your angles, they don't all have to be 90 degrees. They don't all have to be the same, just the opposites. And you'll also notice here that a rhombus is a type of kite. So in a kite, something unique about a kite, sort of the way that it gets its shape, is that it's sides that meet at a vertex, right? These sort of adjoining sides here. These sides have to be the same, right? So it's not about the opposites, but it's about the sides that meet at a shared vertex point. So you'll see that that's also true for a rhombus because all of the sides are the same length. Now, the most specific shape of all is a square. It has to have four sides. They have to all be the same size, and you have to have four right angles. It's a very exclusive shape. So in this hierarchy, right, this square is all of the things above it. It's also a rhombus. It's also a parallelogram. It's also a quadrilateral, right? If you follow up